Hello friends, welcome to the lecture on base flow separation. Up till now, we have seen how the hydrographs are plotted, what are the various kinds of hydrographs like flood hydrograph, unit hydrograph, and how to determine flood hydrograph from unit hydrograph or from given DRH and vice versa. We have seen various terminologies associated with the hydrographs, components of the hydrograph. One of the basic component of the hydrograph is base flow. We all know that if base flow is separated from a flood hydrograph, the resulting hydrograph is called as direct runoff hydrograph or simply DRH. In this video, we shall see how the base flow can be separated from a given flood hydrograph. So let us start. In many hydrographs analysis, a relationship between the surface flow hydrograph and effective rainfall, that is rainfall minus losses, is sought to be established. The surface flow hydrograph is obtained from the total storm hydrograph by separating the quick response flow from the slow response flow. It is usual to consider the interflow as a part of surface flow in view of its quick response. Thus, only the base flow is to be deducted from the total storm hydrograph to obtain the surface flow hydrograph. There are three methods of base flow separation that are in common use, which we are going to see one by one. So let us move towards the first method, that is the straight line method. In this figure you can see a flood hydrograph. This is the figure showing base flow separation methods. We will see the first method, which is a straight line method. This is a typical flood hydrograph in which you can see the time on x-axis and discharge on y-axis. As usual, the hydrograph is having all the components like peak, recession limb, ascending limb, etc. In this method, the separation of base flow is achieved by joining with a straight line the beginning of the surface runoff to a point on the recession limb representing the end of the direct runoff. I will read this sentence once again. In this method, the separation of the base flow is achieved by joining with a straight line the beginning of the surface runoff to a point on the recession limb representing the end of the direct runoff. In above figure, point A, this is point A. In above figure, point A represents the beginning of the direct runoff, and it is usually easy to identify in view of the sharp change in the surface runoff rate at this particular point. There is a sharp change in the surface runoff rate at this particular point, so that the identification of point A, it is quite possible. But point B, marking the end of the direct runoff, is rather difficult. Marking this point B at the end of the runoff, it is quite difficult to locate it exactly. An empirical equation for the time interval n days from the peak of the point B, from the peak to the point B, is n is equal to 0.83 a raised to 0.02. Okay, so to locate the point B precisely from the peak of the hydrograph in n days, this equation is used. N is equal to 0.83 a raised to 0.2, where a is the drainage area in kilometer square and n is in days. Point A and B are joined by a straight line. Point A and point B are joined by a straight line to demarcate to the base flow and surface runoff. The uppermost portion above this line will demarcate the surface runoff and the base flow. It is separating the base flow from the surface runoff. It should be realized that the value of n obtained as above is only approximate and the position of B should be decided by considering a number of hydrographs for the catchment. This method of base flow separation is the simplest of all the three methods. So this is only for the guidance purpose to locate the point B, this equation. You have to take number of such hydrographs for the given catchment, and from that a precise location of B can be estimated. So let us move towards the second method. Second method, as you can see, this dotted line joining the point B to C and A to C, these are the lines separating the base flow. So let us understand how it is marked. In this method, the base flow curve existing prior to the commencement of the surface runoff is extended till it intersects the ordinate drawn at the peak point C in the given figure. In this method, the base flow curve existing prior to the commencement of the surface runoff is extended till it intersects the ordinate drawn at the peak point C in above figure. This point is joined to the point B. This point is again joined to the point B by a straight line. The segment AC and CB demarcate the base flow and surface runoff. This is probably the most widely used base flow separation procedure. It is one of the simplest kind of the procedure. From the vertical drawn from the peak, a line is extended from this particular point A, and this point C, it is again joined to the point B, and this AC and CB will separate the base flow from the surface runoff. So in this method, the base flow curve existing prior to the commencement of surface runoff, it is extended till it intersects the ordinate C from the peak point. Okay, one of the simplest method. And the last method, as you can see the curve over here, curve number 3, we have to understand how the curve is plotted and how the base flow separation is done. So in this method, the base flow recession curve after the depletion of the flood water is extended backwards till it intersects the ordinate at the point of inflection line EF in the figure. Line EF in the figure. This is the point of inflection. Point P is the point of inflection from which the recession limb starts. So the point P, it is having this vertical, and the line, it is extended backward from the point E till it intersects the point F. So what is point E over here? In this method, the base flow recession curve after depletion of the flood water, the base flow curve, it is extended backward till it intersects the ordinate at the point of inflection line. This is EF. Now the point A and F are joined by arbitrary smooth curve. This method of base flow separation is realistic in situations where the groundwater contributions are significant and reach the stream quickly. As you can see, groundwater contribution will be much more higher since it occupies more area in the base flow, and the surface runoff as compared to other methods is less. So by this method, you can separate the base flow. The base flow separation curve, it is demarcating the surface runoff and base flow by the curve AF and EF or FE. It is seen that all the three methods of base flow separation are rather arbitrary. The selection of any one of them depends upon the local practice and successful predictions achieved in the past. The surface runoff hydrograph obtained after the base flow separation is also known as direct runoff hydrograph, that is DRH, as already we have seen. So I hope you have understood the entire base flow separation methods. I request you to go through the standard reference books, try to find out some numericals and try to solve them, understand them. If you don't get the solutions, please feel free to ask me on my email address dnpaitankar@sanjeevani.org.in. Thank you for listening. Happy learning.